Hi, let's get started with Chapter 3, Part 1, Database Systems. As if you watched the video on the what to expect this week, Chapter 3, we're splitting into two parts. First one being database systems, second one being big data. So what is a database? A database is just basically a collection of organized data, just not a collection of data, but it's got a specific organization. Now you find some things that isn't just a separate program, it can be a whole system. How do I manage a group of programs that help manipulate database, interface between users and applications? That's what a database management system is used for. Now, and remember, as we talked about, I think previous, that data is just raw facts. To actually have some meaningful, useful information, it's got to be transformed, it's got to be changed, modified. So that's kind of what we're talking about when we're talking about data fundamentals. Now, data, some of you have been in computers long enough, you know that there's a relationship between data all the way from down what it's at the machine level, where it's bits, zeros and ones, electronically on or electronically off. Bits turn into characters, which are basically 8 bits. Those bits turn into fields, could be like last name, first name. Fields then get added to records. Records are going to have, so if you like think about your school or home address, you got name, address, city, states. All of those are individual fields forming one record. And then if I'm building a dictionary, or not a dictionary, but a phone book, then all of those individual records of your name, rank, and serial number as far as where you live get added to a file, which then becomes that database, and then can be rolled into a database which has different organization, how I can organize the data in such a way that maybe I want to do something. Maybe I want to find out how many states exist in my database, or how many people live in Hickory, or whatever. So I can do other information, other searches and changes with, if I populate a database. So keep in mind, going from bits all the way to databases, there is this hierarchy. They all build on one another, and we'll go from there. Now, in this chapter, you're going to see a lot of terms and definitions, so just bear with me and we'll all suffer through it. But an entity is just basically is data that's collected, a relationship of things that are stored or collected. So whether it's data about a person or a place, a thing. Now, attribute is actually a characteristic of an entity. And of course, data would be an actual specific value of an attribute. And then if I'm talking about how do I organize, I need to find the best way into a database is I need some kind of key, some kind of pointer into this database. And a primary key is a field or set of fields that is used to uniquely, and the key is uniquely identify that record. Just to give you a rough idea. So you got key fields, you got attributes, each one of those fields got last name, first name, hiring date, and it's an entity that's saying, hey, all of these have some kind of relationship in relation to an employee. Now, there's a couple of different ways time has changed. It used to be that every organization had its own little database, and never the two systems. So accounting and HR never talked to each other. Business never talked to all these. So they were each one managed their own little separate entity. But now they've realized, hey, I've got to be able to share information. I've got to be able to find a way to move information across my business, because it makes sense to be able to share information. And that's where this database management or database approach to data management works. So now I put everything in one database, and then let a database management system kind of deal with how do I get what I need for the different functions that are being asked for. Now, of course, I've got all this data. What do I have to think about when I'm building a database? I got to worry about 6 different things. I got to worry about the content. What data should I collect? How much does it cost me to collect that data? Access. Who should get access? When? Is it access to the database, access to a record, access to a field? Are some readable, some writable? So you got to understand what has access. What is the logical structure? How does it make sense to arrange the data? The physical structures, where is the data going to reside? Where's the system going to reside? How do I get access to it? How long do I store information? How long before I worry about the archiving? And then security. How am I going to protect this information? We've seen a lot of data breaches, credit card numbers, stuff like that. So all of these come into play, and any one of them could cause problems. So keep that in mind. Now, when I'm getting data, you'll hear something called a data model. And all it is a diagram of all the entities and how they relate to each other. Of course, there's enterprise data modeling, which is done for an entire organization. And then there's a graphical way to do representation called entity relationship diagrams. And it's basically a diagram that uses graphic symbols to kind of show the relationship between it. In this diagram, you're seeing one thing here says, hey, I'm doing one to many. So I've got one order, could have multiple line entries. And it also says, hey, I got a lot of line items that could be, so this is many to one type of relationship. So it's kind of giving you a way to look at the data in a graphic form and see who relates to who, and an approximate. It isn't an exact count of fields and stuff, but it gives you a relationship. There are, not just in this case between invoice and orders, I got a one-to-one relationship, but I got an order that could have many line items. So I've got one to many, many to one, one-to-one in the different areas. So it's a graphical way of representing this. Now, there's also called a relationship. There's a relational model, a relational database. And we see a lot of that more today, where I've got a series of two-dimensional tables where I've got a row in a table represents an entity, and then a column represents a particular attribute of that entity. So you get two-dimensional table, and then you got an example off to the side here. And then the domain is, what are the allowable values for a particular attribute? So, what are my different attributes here? I'm looking at an attribute, for department. So I should have a range, maybe it goes between 100 and 900. But that domain of department shows me that range of information. Now, what can I do if I was manipulating that data? Well, I can select it, I can project it, I can join it, I can link it. And each one of those has different assets, whether I'm eliminating a row when I'm selecting it, projecting it, eliminating a column to make those searches quicker. Maybe I'm putting 2 or more tables together. So different ways. So just getting used to those type of terms that you may see. Now, because I have data doesn't always mean it's accurate data. So data cleansing is a way of cleaning up, scrubbing, data cleaning the database. How many times have you changed your address? But if you haven't gone back and changed your school address, could that give you information that could be misleading to the school Senate information? So it's basically just a way of correcting, deleting, completing information, inaccurate, whatever. So it just ways to do it. Now, cost of doing that can be expensive. So you got to weigh the cost of doing the cleaning and how much it's going to cost you, whether you're going to kind of go through it and do it at all. Now, relational database, a way of, hey, I want databases to relate to each other. I want to make sure that I can share information across different aspects. Now, what kind of databases are there? SQL is probably one of the bigger ones that you're going to run across. It's basically a special purpose programming language used to modify a data stored in a database. Now, it basically conform to, you can see this ACID properties. Basically means I want to make sure everything is, you see the acronym spelled out, but it's kind of like, I want to make sure that everything in my database is, I can have access to it, it's clean, it's isolated, it's durable, it is going to last. So SQL has been around quite a long time. Just give you a rough idea of a basic query language. Some of you have taken Access. This looks familiar, hopefully, to you in creating a query. You created a query and then generates this output. So SQL, structured query language. Now, what can I do? Well, I can provide user views. I can create and modify data. I can store and retrieve information. I can manipulate and generate reports. All of these things are things that you can do in a database. Now, providing you information is a schema describes what is the relationship, describes that database in its entirety. But it can also be subsets. It just depends on what's more important to you. But it's where do I find access to the required data and the relationship to it? So the schema helps you understand the relationship between the data and its relationships. Now, when I'm creating and modifying, there's two things you can look at, is what is my data definition language and what's my data dictionary. Data dictionary is basically the detailed description of all the data used in the database, and the definition language is just a selection, it's just what's the tool I'm going to use to define and describe the data and relationship. So when you're creating a database, you need to make sure you understand both of those. Now, storing and retrieving, if I got a database, I got data, I got to store it. But the question is how concurrent, how many simultaneous access users do I need to get access to the same record? You don't want to be able to change in your home address or your social security number and doing payroll at the same time. You want to make sure somebody's locked out. So I want to make sure I can control who has access to that information. Of course, we know that I can manipulate and generate reports. So a couple of different areas. You got query by example, more of the graphic view, and data manipulation language, DML, is a language provided by database management systems to help you make queries. And like I said, Access is one that some of you are probably more used to. Now, who does this job? Well, database administrators. They're highly skilled and trained professionals. Probably need a 4-year degree in a lot of cases, but they work with the users to get data needs. They understand the programming languages. They also test, implement. They'll work with application organizations to make sure, because it may be a web page interfacing to this database. So you need to make sure, how does the web page need to get access? What data am I going to share? Who's got access, security, all those issues we talk about when you think about a database. This database administrator has to be able to understand and control all that. Data administrator, who's going to define the consistency of the data, usually reports to the high-level managers. Here's some popular language. Most of you have heard MySQL, SQLite, data, Microsoft Access, one we've used in CTS115. So just some popular languages. Now, sometimes you can get a database as a server. I can go to Amazon and have Amazon store my database and then have it accessed via someone else, through their network. So over the internet, so it's, I'm paying for that service, but then at least I don't have to have the hardware at my location. Maybe even paying somebody else to maintain and actually modify the database. All of those are things negotiable. Now, remember, databases can act as both front end or back end. Front end is what am I going to interact with the people directly. Back end, I'm dealing with programs and applications. Library of Congress is a back end. So hopefully that gives you a rough idea of what this chapter is all about, at least the first half of it. And looking forward to see you next week. Talk to you later. Bye-bye.